All right, welcome everybody on the 6th of December developer meeting where we're going to talk about flow deck flights and tips and tricks how to have your crazy fly bit stable above texture and everything. So this talk is going to be about like tips and tricks about how to achieve that, how to modify your environment to get the, let's say, the most out of your flight performance. So first, as an announcement is that the latest release is out 2023 November for like the Crazy Fly firmware, the CF client, the CF lib. Also, Crazy Radio 2 firmware is out. Yeah, I think that's pretty much it. So if you want to try out the latest and greatest, and also see if we haven't missed any bugs in that release, please go ahead and try it out. So yeah, the flow deck. Yeah, it's a really nice It's like one of the expansion decks that you can get for the Crazy Fly. For the Crazy Fly 2.1, 2.0 as well. And pretty much, yeah, that is like it's an optical flow based internal positioning system, let's say. So that I'm going to explain about that in this presentation. It's usually part of like either the stem bundle or the stem ranging bundle all have a flow deck integrated. So that is actually yeah, that's in a nutshell what the flow deck is. And that's kind of like really makes you have the Crazy fly without a external positioning system, with motion capture that you have to set it up in your environment, or even a local positioning system, or latest lighthouse positioning system. Um, you need to set up something in your environment in order for it to be able to determine its own position. With the flow deck, that's not necessary anymore. So that pretty much means is that either, yeah, you can just pretty much make it fly anywhere as long as there's good texture on the ground, but I will talk about that later. Um, and that makes it already like, from something that you can fly completely like just with a controller to something that is actually a robot, let's say. Or that we can consider a robot that can do obstacle avoidance with like the multi-ranger, maybe add a camera to it, or the multi-zone TOF sensor that ETH Zurich used. I used it during my PhD itself with the multi-ranger to do like swarm exploration without external positioning system. So that allows people to do pretty cool stuff. So yeah, flow deck theory. I'm not going to go too much on it because I would like to also kind of leave the room open for a lot of discussion. So I've also posted some links um, about what I'm all going to tell like underneath the slides. I'm going to release the slides later, but pretty much the flow deck has, as the name already implies, it's kind of based on optical flow. That's kind of like the sensor that's on there, and that's basically like a very low resolution camera that's able to detect the pixel flow from one time or frame to another. And with that, yeah, it's kind of able to, together, of course, with if you have a ranging sensor that's able to determine its height, you're able to determine the velocity of the crazy fly or any other quadcopter that you put it on while it's flying. So of course, like it needs to be looking down. The range sensor needs to also get a good measurement as well. Yeah, and in terms of the positioning system overview, we kind of considered it like, an onboard positioning. You have the same with the lighthouse or local positioning, which means is that the Crazy Fly itself actually internally is able to determine its own position based on, yeah, in this case, it only is onboard sensors. Yeah, also something that I will just show you, but not to go too much into it, is kind of like, the basis of the extended Kalman filter floating measurement model, which is used to kind of like transfer the measurements that it gets, like the flow, the pixel flow, and the range sensor measurements, and convert that to like, a velocity estimation, therefore also a position estimation. But you can kind of like see how all of these are integrated as well. It's also very good to know that if the Crazy Fly itself rotates, even though if it's in the same position, that it will, of course, it will also detect flow as well. Yeah, because that's because of the camera. And so you also have to counteract that. So there's like an, yeah, let me see if I can have a, yeah, so like that, the gyroscope measurements are also included in this measurement as well. So, okay, let's go to actually kind of the gist of this presentation is the tips and tricks for good flights. At least this is kind of like the ones that we know of, but of course, maybe if anybody of you have tips, you can also share that also with us and the rest of the community as well. So yeah, please take off from a natural texture, let's say. That means it's not too much repetition, no blocks, no anything, just like a natural like wood or concrete, like some kind of what we call natural texture is a yes for good flight. A matte surface. I'm going to explain it later why you should try to not go from a too shiny surface. A well lit ambient light room. Why it needs to be ambient. Yeah, I will also show you some videos of that. What is a big no-no? Low or no texture. Of course, like how low you can go with the texture, that's of course like kind of up to you to try out for yourself. I'll add some tips and tricks for that. Yeah, black floor is kind of like the same thing as that's the lowest texture that you can get. Shiny surfaces, like I said, like no, that will do something with the range measurements as well. Low light conditions, spotlight actually, because the crazy fly generates its own shadow and will actually fly over it. So for anybody that has read the blog post, I've actually made a video of like showing kind of couple of these nice conditions that you can fly the float again. So this is pretty an ideal condition, like you have natural floor, a wooden floor, and good lighting and things like that. Since it's a little bit shiny, but not too shiny. But as you can perhaps like see, is that you can see the crazy fly, even though it's small, yeah, fly pretty stably in this condition. Now I'm going to actually show you situations where the crazy fly is not able to really handle it very properly. So yeah, low texture or almost no texture. So this is completely like a blank gray area. And as you can see, is that the crazy fly immediately starts drifting at takeoff. I was even surprised it was even able to detect any like texture. But when it's full on the ground, you can always see a little bit of texture. So it still was able to detect some position. But as soon as it takes off, it doesn't see enough texture anymore. It will start drifting until it looks at the the wooden floor again. So this is a black floor or blackish floor. Interesting to see also is that the let's say the black floor, if you actually fly off that, the positioning estimate already start diverging um, already when it's on the ground. So at the moment that you take off, it already thinks it's completely somewhere different, and it will crash almost immediately. So that's why black floors is the worst kind of low texture environment. Now you can add texture because a lot of these labs have probably like black floors like that. But however, you also have to make sure that you also start off from some kind of texture, let's say, or else the positioning starts diverging, and if you take off again, then yeah, it crashes or things like that, like you see happening here. So at the start of this video, I actually placed it on one of these post-its and was able to determine this position a little bit better. Yeah, low light conditions, even though perhaps it doesn't look as dark to you, but the lights were off, the cameras was very good, and you can actually see that it was let me just play that again if you're able to. It was able to take off, but then it started drifting to the back until it actually saw a bit of the legs of the tripod you saw right there, and then I was able to kind of determine its position again. So also not very ideal, low light conditions. Also, the crazy fly has a tendency to fly over its shadow, even though it's able to still take off here. I will just show you in a minute again. The spotlight actually creates a shadow of the crazy fly, and if you have a sensor that's tracking features, it will of course detect its own shadow and kind of follow it yeah, follows it, and you can actually see that it was trying to take off, but it actually followed its own yeah, shadow until it was gone. But if you have multiple spotlights in the room, which is a couple of hotel rooms that I might not have flown in before preparing for certain like demo presentations, then you will definitely have the problem that will start just kind of drifting until it crashes. So also very something that people are probably not super aware of, but the spotlight and flying over its own shadow. All right. Um, so like it's close to wrapping up, but so like we have some other good tips, good log variables to check if you are in an environment and it's maybe like you're not really sure if the texture is well enough or the light is well enough, then you can always keep it in your hand. And in the sea of clients, you can check if you get any flow at all. So that means it's like you can look at the two log variables called motion.dx or motion.di and just kind of like see like is it even detecting anything at all. So those are things to check. Also good parameters to tune. There is a standard deviation that you can kind of increase, or if you're probably flying around like on an area that has low texture, or you can maybe fine tune to be fly even better. But then of course like any disturbance or any low texture you fly over, it will react quite heavily on that. There's also a motion.adaptive parameter they could turn on. You could try it out because it kind of changes the flow standard deviation based on, I think it's the shutter size at that point. But there's also you can kind of like play around with that. Yeah, tuning PID controllers. That's also possible, like the position PID controller or the velocity PID controller. And don't forget about the CF Client tuning tab that you can of course use for that as well, if you just want to have a better improvement of the flight performance. Um, so yeah, so that was kind of like the tips and tricks and what you can look for. So I would like to hear from you guys, like if you have any other tips and tricks that you would like to add to this, or what your experience is with the flow deck, flying with the flow deck, what your difficulties are. Um, so yeah, like just let us know in both either turning on your microphone or just say it in the chat so I can say it here out loud. Yeah, anyone?
Yeah, I did some experiments with Flow Deck before. Now I'm using Lighthouse at the moment, but I see that you're using sensor fusion to get the best performance out of it. Mainly, I was looking at the sensor, the flow sensor on its own, basically. Because I'm looking into merging it with other inputs, for example, the time of flight sensors. So what I was curious about is how the optical sensor fails, basically. So when it's flying around and it loses tracking somewhere, how does it fail? Does it just lose any position? And how does it recover? Can you tell me something about that? The sensor
Yeah,
itself. Yeah.
yeah, it's sensor itself. Like there's some yeah, of course, like if you go to the product page, there are like I've realized that I didn't actually put the sensor names in here, but you can find it of course on our website.
Mhm.
It has some automatic functionalities that you can kind of change, turn on and off, or kind of adapt with registries. And it also kind of adapts itself, like the in terms of like how big the shutter is and things like that. If there's a very low light condition, um, so it kind of adapts itself or tries to adapt itself. But the problem is that if you're going to fly over an area that has no texture at all, or you're flying into a dark room, yeah, I'm not sure. Like, the only way to recover from that is to fly over something that does has texture. So you just have to hope that at one point in the drift, it will fly something that it can actually recognize as some kind of feature. Um, so what you can do as, of course, like the person that's maybe implements the behavior is perhaps to yeah, look at the variance of the EKF. If the position starts to diverge quite a bit, then perhaps you can give it a command to maybe turn back to a location that you know it actually had better quality positioning, let's say. So yeah, so it's a bit of luck involved. I hope that kind of answers your
Yeah.
question.
Yeah, I found out it's quite sensitive to different kinds of floors. One floor it was too dark, the next one it was too shiny, and in the
Mhm.
end we had a white blanket, a natural blanket on the floor, and that worked very well.
Mhm.
But in the other situation, it was a bit too dark, and then it tracked quite well for some time, and then it lost, and then it gets tracking again. So it was borderline tracking, and yeah, I just wonder what information we can still get out of this sensor in that situation, not in the ideal one, but in
Yeah.
the less ideal, but still working.
Yeah, the thing is that what kind of pops into mind is that, like, you saw before instance like the low texture, like the gray video, that it actually, when it was closer to the ground, it was able to detect something. So I would say perhaps like in your state machine, you would like to maybe, okay, maybe it should go a bit more down so it is able to detect more texture again. Like, like with an airplane, the further up you go,
Mhm.
you see less, let's say. So in that sense, I would say, like, if you kind of see, and that's what you can see from the variance of the Kalman estimator, the EKF for the velocity, that starts to creep up. And then maybe you can say, like, okay, maybe start flying lower. How low, of course, that's kind of like up to you. But that's what I
Yeah,
would keep in mind.
yeah.
There was an hands up
Yeah,
somewhere.
that's me.
Yeah.
Uh, yeah, just yeah, I'm Arno from Bitcraze as well. Um, yeah, just at low level, I think it might be interesting to think about what the flow is, what the flow sensor is. It's basically a high-speed camera with automatic auto gain control on the images, so that actually can cause problem. And that does a cross correlation between two consecutive images and try to give you x and y, the best x and the best estimate for x and y, how these two images have moved. Um, so yeah, and this can fail in multiple way, I guess. But most likely, you're getting from this algorithm, you're getting random noise if the sensor get confused and if the data are not good enough. Do you think Kimberly locking the camera parameter,
Hmm.
can that help? Like, can we do have access to the exposure and do? I can't remember if we have access to that via the registers.
I think we do have access. Also, you get, like, if you go to the login variable motion
Mm-hmm.
dot something, there's actually, or at least in the driver itself, you actually get like a lot of information from the flow sensor itself. Like, either like, the gain, the current gain that's on, or that you can put it on automatic or not.
Yeah.
I think also there's also kind of a sense for the amount of features in your environment as
Mm,
well.
cool.
So that's
That has
why
been
I
locked.
implemented that adaptive STD standard
Ah,
deviation thing.
yeah.
Although when I did some experiments like a long time ago, it was actually more based on the shutter size than the actual yeah, how do you call it, like, the measure of how many texture you had. But that's maybe correlated, right?
Yeah.
If you don't yeah, if you don't have a lot of texture, maybe the gain goes higher. But yeah, but
That's,
there's ways to kind of change it up. But
so if
sorry.
you have a quite controlled environment, an idea could be that if it worked one day and doesn't work the other day, you might try
Hmm.
to lock these settings
Yeah.
to values that work. I mean, as long
uh
as your environment is pretty controlled.
yeah, and I think that's kind of the problem. Like, what I had during my PhD is that my environment was not controlled, and
Yeah,
I was flying
of
over
course.
all kinds of things, like dark areas and things like that. um and yeah, how to solve that, yeah, that's kind of like, just hoping that one point in the drifter will actually see some texture. I guess, like, Pascal, you mentioned that you're going to looking into fusing, for instance, like perhaps like the multi-ranger sensors with the position estimator, and that's kind of also a good way to solve that issue as well. Because then you don't have only one value of the velocity, but you also can use, like, for instance, like this how quickly you're going towards the walls. For instance, you can merge that as well. Like that's kind of like the whole principle of SLAM and localization. Yeah, so that's ways to solve that. Maybe a flow deck looking at the top, maybe as well.
Yeah, I
For
think people
forward.
have been trying that.
Yeah.
Mostly to avoid jumping over obstacles. If you track the ceiling and the ceiling is flat, then
Yeah,
then
true.
you can fly over tables and stuff. But if the ceiling is flat, it's a big if.
Yeah,
Most
true.
times.
Yeah, that's like I think one of my first works was to actually put a camera for it and to use like optical flow divergence, which you don't get from the sensor from the flow deck. It doesn't know if it's yawing or not, and that I forgot to actually mention. If you yaw quite a lot, then you will also get quite some drift because the flow deck's not able to distinguish between flow that's created by yeah, it turning around. Yeah, so hopefully newer flow sensors and perhaps, I don't know if anybody looked into the new flow sensors, if they have such a possibility to get more of like pixel based flow and not full global flow of the camera. So then you can actually, yeah, do something cool with flow divergence and like yaw estimation and things like that. So anybody else that would like to pitch in into their experience with the flow deck?
Yeah, I have another question because you were mentioning flying across tables. So how sensitive is the flow sensor with respect to the floor not being completely flat? It can be a couple of centimeters, but it could be also objects on the floor with 10 centimeters or something like that. So what differences can it cope?
Yeah, that's a very good question. The thing is that like you have the range sensor to consider. Thus, of course, it will get a very good jump, and you will like the crazy fly would respond to that. And other than that, even though if you would, for instance, just fly over a table by itself, and maybe you do kind of disable the range only being determined on the range sensor, or maybe you use like lighthouse, but still the flow deck. If you would fly over a table, if you just look at the camera footage, then at one point you just have a very quick change, let's say. If you were flying at 2 meters, for instance, then the floor is going a little bit slower, and then suddenly you have a table that moves a little bit faster because that's closer to the crazy fly, and then suddenly you would detect more flow. Even though, for instance, like the range sensors maybe still detecting the floor or something like that. So yeah, that's an interesting thing to actually try out. Because usually if you would fly over a table, it would just like floop.
Yeah.
Yeah.
That's why I was asking about a couple of centimeters or So
yeah, a couple of centimeters I think is going to be fine. I think you have to kind of be a little bit more worried if it starts to be like a half a meter to an up or something like that. But I think it will be a nice experiment to like disable the range sensor in some sense and make it fly on and just like see what the flow is then doing if you just fly over the table like that. But I think I think it's going to be
I think the table is too much, but that's what I said. Well, there can be stuff on the floor, and that could be messing around with the optical flow deck.
Yeah, so in some sense, but like as I already showed in the let's say like I had some the flow is already quite noisy, so I think therefore I think that like a couple centimeters it's not going to make that much of a difference. But
yeah, exactly. My feeling is that this is going to be within the margin of error of the measurement we have anyway.
Yeah, exactly, and it's never going to be like a perfect like a perfect position estimate anyway. Like you can if you use the lighthouse and use the flow deck next to each other. Maybe you disable the flow deck or something like that, or you can see that the ground truth doesn't coexist with the flow deck's only based measurement. So that's kind of how this is relative positioning. So, but yeah. Okay. Any other questions?
Yeah. I have another one, but
Sure, go for it.
so what about a field of view of the flow sensor, especially when I'm trying to fly multiple drones in a swarm? So how far away should I keep them away from each other when they're, yeah.
Yeah, very good question. What is the field of view of the optical flow sensor again? It was about 40 degrees or something like that. I see that Hannah is there. Do you remember?
I
You
think
worked
it's
with it.
around 45 degrees. I think it's in the code at least. I can check. I can come back in half a minute.
Yeah, okay, yeah. I have too many windows open, so I cannot double check, but I can indeed remember it was 45 degrees.
In total, or is it 90 in total then?
No, it's 45 degrees in total, right? Yeah.
Yeah, 90 is too much.
90. Yeah, no,
okay.
90 is too much. It's not on a very wide lens camera.
Yeah, so it's 22.5 in every direction basically then.
Yeah, exactly. And then yeah, if you have a crazy fly flying close underneath it, and also you have to take in mind that the range sensor also has a small field of view as well. But we don't like, at least in the code, we don't assume it has a field of view, but it does. So it might also detect the other crazy fly a little bit sooner than you would expect, but that's it's all part of the data sheet.
Yeah, when the
42.
height is different. Oh,
Hannah?
42 degrees.
42. Ah, okay,
Yes.
nice.
Oh.
Yeah. So yeah, I think if you're going to have crazy flies flying over each other, perhaps some margin is advised. Let's say.
yeah. It's more like next to each other on different levels, but it's good to know how careful we should be with that. But 42, it's not too bad though.
No, yeah, and also like I said before, like the spotlight flights. Yeah, like it's like, especially it can also fly over other crazy flies as a shadow as well. So just be aware of that. That you need some good ambient light in the room that you're flying with.
Okay, I'm afraid that was my last question now.
Okay, yeah, no, it's very good questions. Anybody has some other tips, tricks, / questions / anything else about the flow deck now in particular? No? All right. No, that's great. Yeah, so we usually also reserve the last part of the developer meeting for just generic questions about the Crazyfly, about the client or the CFlib, or if you're just wondering how we're doing, that's a good question as well. But that's kind of like, now you can also ask more generic questions if you like. Support questions.
And I guess we are gonna stop the recording.
Yes, that's a very good one. Yeah, that's a very good one. I will stop the recording now. That will actually end the flow deck part of things.
And we'll be back in January, I guess.
Yeah. I think actually, because it's the first week of January, it's not going to be a lot of us around. So I think I'm just going to probably propose this a generic support question hour or something like that. Because we don't have that much to prepare. But let's see.
So dev meeting is back in February then, first week of February.
Yeah, the dev meeting about this particular topic is February, but January you can still do a dev meeting, but just like an open one.
Okay.
Yeah. All right. I will stop the recording then for the flow deck.